Hello and welcome to chat section 4.3. This is on the constitutional isomers of alkanes. It's something that we have talked a little bit about in chapter 1 whenever we had to draw all the constitutional isomers for a molecule. But in this case, we're talking a little more specifically about the number of possible constitutional isomers that can happen for a molecule. So you can kind of think of it like those toys, Legos. If you ever play with those, if you had a small box of Legos, there were a certain number of ways you could put the Legos together. But as you increase the number of Lego bricks, there seemed to be more and more like infinite types of things you could build with them and ways they could go together. And the same thing holds true for alkanes as well, because if you have C3H8, there are only really three ways that you can make some kind of structure here with that, and that's this. But if you have C4H10, now you have two different types of structures you could make. You have this one, and you have this one. And it turns out as you can increase the number of alkane or carbons and hydrogens involved, you get way more and way more. So C10H22 has 75 different isomers. That's a lot of isomers. So your book tries to give you a little bit of help in how to actually go about drawing these. And more or less, they say that if you are given some type of question about isomers, and it's like, take this formula, draw all the isomers. Well, basically it says to start with a non-branched version. 1, 2, 3, 4, 5. Great. And then every time you branch, you should name it. That way you don't get lost as to what you're actually dealing with. And by that, I mean, this is an isomer. And this is 1, 2, 3, 4. So this would be 2-methyl butane, and we know it's methyl because of the methyl substituent, and it's butane because of the 4-carbon long parent chain. All right, another isomer could be this one, and this is got a 1, 2, 3 long parent chain, and it has 2 methyl substituents. So this would be 2,2-dimethyl propane. The prop comes from the parent chain length of 3, and the 2,2-dimethyl is from the 2 substituents. And these are the constitutional isomers for C5H12, and obviously the more carbon, you get more constitutional isomers that are possible. Yeah, so this is more or less section 4.3.